Well, hello. We're going to be starting chapter 6 today, and in the start of chapter 6, we're going to be focusing on the law of sines and cosines, which are things that hopefully you remember from last year, but if not, I will try to set you straight, okay? So we have learned to solve right triangles using SOHCAHTOA definitions, but we can only use this idea, SOHCAHTOA, if there's a hypotenuse, which is a right triangle, right? Now what we're going to do is review and learn how to solve oblique triangles. And when we talk about oblique triangles, those are triangles that don't have a right angle. So all triangles have 6 pieces of information. We know that there are 3 angles and 3 sides. The angles are labeled A, B, and C. And the sides are opposite the angles, and our lowercase letters are used, lowercase a, lowercase b, and lowercase c, okay? So in order for us to solve an oblique triangle, we have to know at least one side and 2 other pieces of information, okay? So again, the reason that right triangle trig doesn't help is because without a right angle, there is no hypotenuse. So we need something else. So we're going to start with what's called the law of sines. If you want to check out your textbook for a proof of the law of sines as far as why it works, that's on page 464. And we're able to use the law of sines in the following cases. We're able to use the law of sines if we have angle, angle, side, if we have angle, side, angle, or side, side, angle. And what I mean about that is that if we have triangles, okay, that I have an angle, another angle, and then a side that's not between those angles. If I have an angle, a side that is between 2 angles and another angle, or if I have a side, and another angle. At that point, then I'm able to use the law of sines. And when we use the law of sines is given as A over the sine of angle A, the length of B over the sine of angle B, and the length of C over the sine of angle C. So we need to have one of those ratios. And so you have to know a side and an angle opposite that side. Notice in this SSA case, we have the side and an angle, well, the angle and the side opposite that angle. In this case, it doesn't look like we know this angle, but if you know 2 angles of a triangle, you know the third one, right? So we can use the triangle sum theorem to find the third angle, and then the side opposite that angle would be in our ratio. And then here for angle, angle, side, we have that angle and the side opposite that angle. That's going to be our base ratio. Okay, so the law of sines will be nice and easy for us to review and use. And there's also the law of cosines. The proof for the law of cosines is on page 465 of your book. And what we use law of cosines for is we use law of cosines when we have side, 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 or if we have side, angle, side. Okay, by side, 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 meaning that we have information about all 3 sides. And by side, angle, side, I mean that we have 2 sides and an angle between those sides. Again, notice there would be no way for me to set up the law of sines in this problem. We don't know an angle and a side opposite that angle. So I don't memorize like SAS is this, AAS is this. I just think, can I set up a ratio? If I can set up a ratio, I use law of sines. And if I can't, I use the law of cosines. One thing with the law of cosines is that when you, so let's talk about the law of cosines. So the law of cosines, we have a squared equals b squared plus c squared minus 2bc times the cosine of a. And then we can kind of move those letters around, all right? One thing to notice about the law of cosines is that the side that you have here is a squared matches up with this angle that's here, okay? And then the other 2 sides, b squared plus c squared, are then found here in this minus 2bc times the cosine of a. We really have to be cautious of order of operations when we utilize the law of cosines, and we'll do that together, okay? So the law of cosines can be written as other things. That's what this arrow is for. I'm not going to write it out. I think I have these online. But like you can re-isolate the cosine of A to be these different things. I don't like that, to be honest with you. I think that we should just use the beauty of the three original law of cosines, and then we can manipulate using inverse operations to solve for what we need to. One thing is that if you start with the law of cosines, stick with the law of cosines. I know the law of sines is a lot nicer, but I'm going to just put that little note here. If you start with law of cosines, stick with it. The reason is that what's nice about the law of cosines is that when we think about solving for an angle, when we use inverse cosine will give us angles in quadrant 1 and in quadrant 2. So it'll give us obtuse angles in addition to the acute angles. However, if we think about the law of sines will never give us an obtuse angle, right? Because if we use inverse sine in our calculator, what's going to happen is that it gives us negative angles, which can't be in triangles, or angles in quadrant 1, which are acute and not obtuse. So once you start with the law of cosines, stick with it just in case there's an obtuse angle in that triangle. Okay? All right, enough of me talking, for goodness sakes. Let's do some problems. So in these examples, we're going to solve the triangle, and that means that we're going to find all of our missing information. This says to draw a triangle and to identify the case. And I think when you can draw the triangle if you would like to. I sometimes just see, can I set up a ratio? Okay. So in example 1, I have angle A, side B, and side C. Can I set up a ratio and use the law of sines? Do I know an angle and a side opposite that angle? I sure don't. And there's no way for me to find that. So because I can't use the law of sines, I'm going to use the law of cosines. Okay. If you don't like that train of thought, what you can do is you could, for example, label the different sides. You know that A is 50 degrees, angle A is 50 degrees. Side B has a length of 15 and side C has a length of 30. We can see that as far as what we've labeled, we have a side, and then in between those two sides, we have an angle. Again, that's the SAS case. That's going to be the law of cosines. Okay. For me, I just look to see if I can find a ratio and I go from there. Okay. So I see that I can't use the law of sines, so I'm going to have to use the law of cosines. And I see that I have angle A, so I'm going to use the form of the law of cosines involving angle A, which is going to be A squared equals B squared plus C squared minus 2BC times the cosine of angle A, which is 50 degrees. Now, what's nice about this is that we can just enter that right in. Everything is on the right side of the equation, so I can punch that in. Notice we are in degrees, so we would want in our calculators to make sure that we are in degrees. So if we're using one of the multi-view calculators, make sure that we change that to degree mode. And if we're using a graphing calculator on the homework, make sure that we change that to degree mode also. Okay. Just for expediency for the video, I'm just going to type things in my graphing calculator, but we can always type these in the scientific calculator as well. Okay, so here I'm just going to type all of this in, 15 squared plus 30, not to the negative 1, plus 30 squared minus 2 times 15 times 30 times the cosine of 50, and I get this 546.491-ish. Okay, so I'm going to write it down as a landmark, but I'm not going to use that number. I'm going to use the number that's in the calculator to find A, and I'm going to need to take the square root of that particular answer. And I find that A is going to be 23.38. I guess I'm rounding these to the nearest hundredth. I guess sides often, I'm looking at what I'm doing. Sides I usually round to the nearest hundredth, angles to the nearest tenth of a degree. Okay. All right, so now that I've started with law of cosines, as nice as it would be to set this up using the law of sines, it's going to be safer if we don't do that and if we stick with the law of cosines. So we can decide whether we want to look to find angle B or if we want to find angle C. Okay, I'm just going to choose to find angle C, and I'll show you why. Let's say that I chose to find angle C. If I want to find angle C, that means I'm going to start with C squared over here on the left. And then I'm going to have the other two sides, 15 squared plus 23.38 squared minus 2, and then times 15 times 23.38 times the cosine of C. Now, I want to make sure you understand that all of this is not the coefficient of C, of the cosine of C. This is the only thing that is the coefficient of C. What we need to do is we need to move these two over by subtracting them. Then we can divide by this here. Okay, so don't do, so just be very cautious about that. You can't enter all of this in the calculator and then divide it. No. We have to move 15 squared over. So I'm going to take 30 squared. I need to subtract off 15 squared. And now I need to subtract off 23.38 squared. And then if I subtract that off, now I need to divide by this coefficient of the cosine C. So I'm going to divide by, in parentheses, I'm going to put -2 times 15 times 23.38, okay? If you don't put the parentheses down there, the issue is that it'll just divide by -2, and then it'll multiply by the other pieces. But we want to divide by all of that stuff, so make sure you're cautious there. And you can use multiplication signs instead of parentheses right here, okay? I'll do that in a different problem later. So essentially what we've done is we've said that the cosine of C equals -0.183. And now we want to find what angle C is. So if we take the inverse cosine of our answer, we see that the measure of angle C would be about 100.5 degrees. Remember, when you round, you just look at one decimal place. All I'm doing is looking at the 4. The 4 tells me to keep the 5 if I'm rounding to the nearest 10th. So the measure of angle C is going to be 100.5 degrees. The reason I wanted to find that first is because if we had tried to use the law of sines for that, we would have been out of luck. Remember, inverse sine won't give us an obtuse angle. We would have to do different work for that. So that's what's nice about sticking with the law of cosines. Well, now we have the missing side A. We have the missing angle C. Now we need the missing angle B. And as fun as it would be to use the law of cosines again, it does make the most sense to use the triangle sum theorem. And we're going to take 180, subtract off angle A, subtract off what we have for angle C, and that's going to give us my measure of angle B. So my measure of angle B is going to be about 29.5 degrees. Okay, and notice I'm using the approximately equal to symbol because I'm rounding all these guys. Alrighty. Okay, let's try another one. Number 2. It says angle A is 10 degrees, side A is 4.5, and B is 60 degrees. To be honest with you, I see right away that I can set up this ratio. And so I'm going to right away start with the law of sines instead, because I'm able to set up this A over the sine of angle A, okay? If you were to draw a triangle, what you would find is that we have angle, side, which we can use the law of sines for, okay? But I have this here, and I have 4.5 side A over angle, the sine of angle A. And then I also know angle B, so the angle will also go on the denominator. I'll have the sine of 60 degrees. And since that was angle B, I'm going to have that this is side B up top. And then the beauty of the law of sines is that we just solve by cross multiplication. And then what you can see is that we would have b times the sine of 10 equals 4.5 times the sine of 60. So essentially what that means is that b would be 4.5 times the sine of 60 degrees, all divided by the sine of 10. So I don't need to see like all the algebraic work, but I love the setup and I love seeing what you're entering into the calculator, okay? So in here, I'll put in 4.5 times the sine of 60 divided by the sine of 10, and I find that side B is about 22.44. Okay. Now, of course, it would be nice for me to set up one other law of sines proportions, but in order to do that, I would need to know what angle C is. And I can find angle C very easily by taking 180 minus angle A minus angle B. And that tells me that my measure of angle C is 110 degrees. I don't use the approximately here because they gave me 10 and 60 as actual degree measurements, so I don't necessarily need to think about rounding there. All right. So now that I have that, I can again use this 4.5 over the sine of 10 degrees as my beginning ratio. And because I know that this angle C is 110 degrees, I know that I could put C on top of that and then solve this proportion. So I can see that C is going to be 4.5 times the sine of 110 all over the sine of 10 degrees. And if I put that in the calculator, I won't waste our time doing that, you should get 24.35. Right? Let's look at example 3. In example 3, I have 3 sides. Am I able to set up a ratio with a law of sines? I'm not. So I'm going to have to use the law of cosines. And it doesn't matter which one you start with first. Out of habit, I always start with the biggest one. But you could start with whatever angle you wanted. Let's say that you wanted to start with angle A just because, okay? So in that case, if we wanted to start with angle A, that means that we would start with side A over here. Again, I can't use law of sines. I don't know an angle to make a ratio with. So I'm going to have 31 squared equals 52 squared plus 28 squared minus 2 times 52 times 28 times the cosine of A. Once again, make sure that we're subtracting these off, and then we're dividing by the coefficient of the cosine of A. Okay, so again, 31 squared, I have to subtract off 52 squared, and also subtract off 28 squared and move those over to the other side. Then I'm going to divide by all of this, by -2 times 52 times 28. Again, put that in parentheses. And I see that the cosine of A is about 0.868. I'm not going to use 0.868. I'm going to use what's in my calculator, and I'm going to take the inverse cosine of that because I'm looking for the angle. And I find that the measure of angle A is about 29.8 degrees. Okay. So then I can find another angle. Again, even though it's tempting to set up with the law of sines, it's a bad plan because there might be an obtuse angle that the law of sines won't tell us about, okay? So let's try to use angle B. So I have 52 squared equals 31 squared plus 28 squared minus 2 times 31 times 28 times the cosine of B. Since 52 corresponded to side B, we're looking for angle B. So again, in the calculator, I'm going to be taking these two away. 52 squared minus 31 squared minus 28 squared. And now I want to divide by the coefficient of cosine B, -2 times 31 times 28. And so I have that the cosine of B is about -0.552. And so I'm going to take the inverse cosine of that answer. And good thing I didn't use the law of sines, because this triangle has an obtuse angle. And had we tried to use the law of sines, we wouldn't have been able to get an obtuse angle, because again, the inverse sine in a calculator only gives us angles in quadrant 4, which are negative angles that don't exist in these triangles, and quadrant 1, which can't be obtuse. Well, now we have the nice easy part. We know 2 of these angles, so we can take 180 minus 29.8 minus 123.5, and that gives us the measure of angle C, which will be about 26.7 degrees. And I don't need to see this subtraction work. I'm just being dramatic. That's what I do. All right. What about something like number 4? In something like number 4, I look to see if I can set up a ratio. It doesn't look like I can. And sometimes I just double check. Can I find an extra angle? I can't. So this is just going to have to be law of cosines. And they give me angle B, so I'm going to start by using that and to try to find side B. So take a second and try to do this one, because this one is really similar to number 1. So press pause and see if you guys can do this number 4. Okay, and then I'll show you what the answer should look like. Alrighty, so here's what I ended up with. The first thing I did was find what side B was, which was about 6.48. Then I decided to go in numerical order and, wow, in alphabetical order, and find angle A first and then angle C. If you found angle C first, I just want you to know that as far as like how checking your answers goes, you might be like 1/10 off, like really close. When I found angle C first, I got 125.8 degrees, and then angle A was 28.2 degrees. Here, when I found angle A first, I have 28.3 degrees, so this was 125.7. Again, the reason that is because we're using that rounded value of 6.48. So the more decimals that we chop off, the farther away it is. So just be cautious about that and know that like in a test situation, as long as I see your work, either of those would be okay with me. Okay. All right. Great. So hopefully that went well for you guys. Example 5. A bridge is to be built across a small lake from B to C. So here's our little bridge. The bearing from B to C, oh yay. The bearing from B to C is south 41 degrees west. From a point A, 100 meters from B, the bearings to B and C are south 74 east and south 28 degrees east, respectively. Find the distance from B to C. All right, so let's first look for here. It says that the bearing from B to C is south 41 degrees west. When we're dealing with bearing, that means that we are going to need to draw a north-south line, a vertical line. And again, it's going to be south 41 degrees west. So this is telling us that this is 41 degrees. Okay. Next, this south 74 east is from point A to B. So if I draw another vertical line, okay, from A to B, south 74 degrees east, so southeast, so this right here would be 74 degrees. And from A to C, that's going to be south 28 degrees. Okay, so this long one here, from here to here is 74. This little one is 28. Okay. Well, our goal, you guys, is to find the distance from B to C. And notice that B to C is part of that triangle, ABC. So what we want to try to do is find as many angles as possible that are in the triangle. Okay. And one very easy one that we could do is that we could find this one that is in here. Okay. We know that this angle is 74. This little angle is 28. So as far as this angle here, what I could do to find this angle is I could take 74 minus 28 degrees, and that's going to give me this angle here, which is going to be 46 degrees. Okay. So again, this whole 74 minus this 28 tells me that this angle here is going to be 46 degrees. So I have that part of the triangle. And maybe, maybe what we want to do is kind of like draw a different triangle here that's not quite as messy. And here we know that this is, again, 46 degrees. Okay. And then the other thing is that, again, it says from a point A is 100 meters from point B. So we do know that this distance from here to here is going to be 100 meters. So maybe I should label these sides or these angles. So that's going to be 100 meters as well. Okay, so let's see what else we could do. I know that this is 41 degrees, right? And I could subtract from 180, but notice that doesn't give me the angle inside the triangle. But that's okay. Look at this. What we're going to do next is use parallel lines. Aren't these north-south lines that we drew parallel to each other? And what that means is that I actually know this angle because it's an alternate interior angle with this 74 degrees. So notice that this 74 degrees here is an alternate interior angle. So this, my friends, is also 74 degrees. I should make that a different thing so it doesn't look congruent to the 74. Okay. So again, we use the alternate interior angles to say that, okay, well, if this angle here is 74 degrees, by parallel lines, this angle would have to be 74 degrees. And then from there, we're able to find this angle. Okay. To find this angle, we can take 180 minus 74 minus 41. And so we find that that is 65 degrees. Well, I can label that right here. Okay. And if I know that that is 65 degrees, now I'm able to find this angle. So the next thing is I would take 180 in the triangle, 180 minus 46 minus 65 degrees, and I find that that is going to be 69 degrees. Again, you could label it in here too. Okay. So that's kind of like the messy way of using the bearings to try to find the different angles of that particular triangle. Okay, and the reason that that's nice is because what we're doing is we're looking for the distance from B to C. Okay, I'm going to call that A because it is across from angle A. And if we're looking for that, and I'm deciding on using law of sines and cosines, look at this. Across from the angle of 69 degrees, we know that that's 100 meters. So that means that we can use this to set up our law of sines because we do have that ratio that we can use. Okay, so I will take 100 over the sine of 69 degrees equals, I'm looking for A, and then that would be over the sine of 46 degrees. So I know that A is 100 times the sine of 46 degrees over the sine of 69 degrees. And I can just punch that right in the calculator. Nope. And I can see that A is going to be about 77.05. The unit we were dealing with is meters, and so we are all set there. All right, so that's kind of the new thing, the stretch, because I know a lot of times we're like, well, we did this last year, and we did, except now that we've talked about bearing, we can add that component to it as well. Okay, all right, a couple things. Okay, yeah, one other example. Okay, so this says that a 10-meter telephone pole casts a 17-meter shadow directly down a slope when the angle of elevation to the sun is 42 degrees. Find theta, which is the angle of elevation of the ground. Okay, we're focusing, you guys, on this triangle right here. All right. In this triangle, we know that this, and I don't know if you want to draw it down here or what. Is that helpful to kind of take it out of the context? This is going to be 17 meters. This is going to be 10 meters. We know this is 42 degrees. And, oh no, this whole thing is 42 degrees. Sorry, this whole angle is 42 degrees, so we don't want to label that. And then this is 48 degrees. Okay, so what we could do is if we did want to find what this angle is, because essentially what's happening is that we know that this large angle, let me put it a different color, is 42 degrees. What we're looking for is we're looking for this little angle, theta, in this little triangle. So if we could find this angle of the triangle, we could subtract that off of the 42 and hence get our angle theta. So let's try that. Are we able to set up a ratio for the law of sines? We do. We do have an angle and a side opposite that angle. So I'm going to take 17 over the sine of 48 degrees equals 10 over the sine of, I don't know what this is. Sorry, so I guess I should label that. I'm going to call that angle B, because that's how it's labeled in the picture in that triangle ABC. And so I find that the sine of B is going to be 10 times the sine of 48 degrees over 17. Now, when I put this in the calculator and I get, like, let's say you put this in and you have 10 times the sine of 48 divided by 17, that is not the measure of angle B. What is that? Yeah, that is the ratio of the sine of B. Remember that we do have to use the inverse sine. So you could use inverse sine and just type this in, or if you were like, oh shoot, I should have done that, just take the inverse sine of the answer, and that will give you what your angle B is. So angle B is about 25.9 degrees. And so therefore what we want to do is we wanted to find this angle theta. And again, what it looks like is that this angle theta is this large 42 degree, okay, it's not that large, but that 42 degree angle of like the huge right triangle minus the angle B of the triangle ABC. And so we said that angle B was about 25.9 degrees. So that means that our angle theta could be about 16.1 degrees. Okay. So again, this is a case where we used inverse sine, and we can use inverse sine to solve triangles in the law of sines. We'll talk more about that in the next lesson, but just remember that here when we're solving for an angle, we do have to use the inverse. Okay. There are a couple problems in the text that are much easier if we remember some characteristics of parallelograms. So let me remind you about some of those different pieces. First of all, the diagonals of a parallelogram bisect each other. Okay? They cut each other in half. That means that from here to here is equal from here to here. So like if this was length x, this would also be length x. Now that doesn't mean that this is length x, it just means that this length is the same as the other length that's here, okay? Remember that the opposite sides and opposite angles of a parallelogram are congruent. And consecutive angles, meaning angles that come are next to each other in the parallelogram, are going to be supplementary. So this says to complete the table by solving the parallelogram shown in the figure. And the lengths of the diagonals are given by C and D. So when they are talking about this angle, this side C, this C is this entire diagonal that's right here, okay? This D is this entire diagonal that we have here, righty? Well, in this case, it's telling us that A is 4, and that B is 8, and that this angle theta is 30 degrees. Well, one really easy thing that we could find right away is we could find what phi is. We see that theta and phi are marked in this triangle as consecutive angles. So I'm going to find this one first. We don't always have to go in order, okay? So to find this, I'm going to say that to find phi, I'm going to take 180 degrees minus 30 degrees, okay? And so that is going to give me the 150 degrees. So that's part of it, okay? So now that I know that that angle is 150, let's see what else I could do. Maybe I would want to move on and do, I don't know. We could move on and do C or D next, excuse me, if you want it. And the reason is because if we look at the triangle that we have with that angle that's here, we know that this is 4, this is 8, this does not look like 30 degrees, but it's 30 degrees, and I'm looking for this angle D, or this side D, the side length D, okay? And one thing we can do is you might say, oh, well, I kind of want to use the law of cosines for this, but again, we don't know, but we don't know what length D is, so we can't set something like that up. So because we don't know both the angle and the side that's opposite that, we're going to have to use the law of cosines. So we could say that D squared equals, then use the other two sides, 4 squared plus 8 squared minus 2 times 4 times 8 times the cosine of 30 degrees. And then because that's all on one side, I just type that right in the calculator. 4 squared plus 8 squared minus 2 times 4 times, times 8 times the cosine of 30. And I get that D squared is about 24.574. And taking the square root of that answer, I have that D is about 4.96. Okay. So maybe based on what I have in the picture, I would find letter D second. So then what would I do to find side C? Well, notice that side C is part of this triangle. And we know that this side is 4 because the opposite sides of a parallelogram are congruent. This side is 8. And in number 1, well, when we found phi, we found that that was 150. And this is going to be letter C here. Again, since we don't know an angle and a side opposite that angle, we'll have to use the law of cosines. So I'll say that C squared equals 4 squared plus 8 squared minus 2 times 4 times 8 times the cosine of 150 degrees instead. And then I can just substitute this in. Oops. All right, and I see that C squared is about 135.426, and taking the square root of that answer, I get that C is about 11.64. Okay, So I did that third over here. Okay. And again, you could do them in any order, like you could have done what I did in number 2 before this. But again, in order for me to get side C, there's no way I could have done that without getting the phi value. I think that's it for today. Yes, it is. Okay, so that's a little bit about the law of sines and cosines to get you guys going. Again, you will need to have those memorized. You cannot have a formula sheet for law of sines and cosines, okay? All right, let me know if you have questions. Have a great day.